Hi friends, this is Atanu Chaudhary of SureSolve. Today in the first part, we'll take up the SSC CGL solution set 40 on trigonometry 4 from suresolve.com and solve the first 5 questions. Let's solve the first of these difficult set of problems on trigonometry. Question 1 is, if cosec 39 degree equal to P, the value of 1 by cosec square 51 degree plus sin square 39 degree plus tan square 51 degree minus 1 by sin square 51 degree sec square 39 degree is option A p square minus 1, option B root over p square minus 1, option C 1 minus p square, and option D root over 1 minus p square. From complementary trigonometric function concepts we know sin 90 degree minus theta equal to cos theta, cos 90 degree minus theta equal to sin theta, and tan 90 degree minus theta equal to cot theta, where theta is an acute angle. So, in the direct expression, we'll substitute for sin square 51 degree, cos square 39 degree, and for tan square 51 degree, cot square 39 degree. The expression becomes then E equal to sin square 51 degree plus sin square 39 degree plus tan square 51 degree minus cos square 39 degree divided by sin square 51 degree. Equal to cos square 39 degree plus sin square 39 degree plus cot square 39 degree minus cos square 39 degree divided by cos square 39 degree. Equal to 1 plus in the brackets cos square 39 degree minus 1 minus 1. Equal to p square minus 1. Answer is option A, p square minus 1. Solved easily in quick time. Let's solve the second problem. Question 2 is, if sec theta equal to x plus 1 by 4x, where theta greater than 0 degree and less than 90 degree, then sec theta plus tan theta is option A x by 2, option B 2x, option C 2 by x, and option D x. Using the relation sec square theta minus 1 equal to tan square theta, we would derive the value of tan theta. We have here sec theta equal to x plus 1 by 4x. Or sec square theta minus 1 equal to x square plus 1 by 2 plus 1 by 16x square minus 1. Or tan square theta equal to x square minus 1 by 2 plus 1 by 16x square equal to x minus 1 by 4x whole square. So tan theta equal to x minus 1 by 4x. Adding the values of sec theta and tan theta, we have sec theta plus tan theta equal to just 2x. The value of tan theta equal to minus in the brackets x minus 1 by 4x is ignored because it would have given the target value as 1 by 2x, a value out of the choice value set. Answer is option B 2x. Easily solved in mind. Let's solve the third problem. Question 3 is, if tan theta equal to 1, then the value of 8 sin theta plus 5 cos theta divided by sin cube theta minus 2 cos cube theta plus 7 cos theta is option A 2.5, option B 2, option C 3, and option D 4 by 5. First observation is, the target expression contains only sin theta and cos theta, whereas the value of tan theta equal to 1 is very significant. This value plays the key role in solving the problem quickly. We have tan theta equal to 1 equal to tan 45 degree. So sin theta equal to cos theta equal to 1 by root 2. The direct expression can be expressed now as E equal to 8 sin theta plus 5 sin theta divided by sin cube theta minus 2 sin cube theta plus 7 sin theta equal to 13 divided by, in the brackets, minus sin square theta plus 7. Equal to 13 divided by 13 by 2 equal to 2. Answer is option B, 2. Solve easily in mind. Let's solve the fourth problem. Question 4 is, if 7 sin theta equal to 24 cos theta, where theta greater than 0 degree and less than pi by 2, then the value of 14 tan theta minus 75 cos theta minus 7 sec theta is option A 1, option B 3, option C 2 and option D 4. Comparing the direct expression with the given expression, we find that the value of tan theta in the direct expression can easily be derived directly from the given expression as 7 sin theta equal to 24 cos theta or tan theta equal to 24 by 7. We would use the value of tan theta now to get the value of sec theta and so of cos theta. We already have tan theta equal to 24 by 7 or tan square theta plus 1 equal to 24 square divided by 7 square plus 1 or sec square theta equal to 576 divided by 49 plus 1 equal to 625 divided by 49. Or sec theta equal to 25 by 7, as theta being greater than 0 degree and less than pi by 2, sec theta is positive. So cos theta equal to 7 by 25. Substitute these values in the direct expression. E equal to 14 tan theta minus 75 cos theta minus 7 sec theta equal to 14 times 24 by 7 minus 75 times 7 by 25 minus 7 times 25 by 7. Equal to 48 minus 21 minus 25 equal to 2. Answer is option C 2. Last problem now. Question 5 is, the minimum value of sin square theta plus cos square theta plus sec square theta plus cosec square theta plus tan square theta plus cot square theta is equal to option A 1, option B 7, option C 3 and option D 5. We know from our algebraic experience how to find the minimum value of a quadratic expression. To apply the standard minimization method, we have to simplify and transform the given expression in suitable form. Let's simplify the expression first. Using standard trigonometric simplifying relations of sin square theta plus cos square theta equal to 1, sec square theta equal to tan square theta plus 1 and cosec square theta equal to cot square theta plus 1, we transform the direct expression wholly in terms of tan theta and cot theta as E equal to 1 plus tan square theta plus 1 plus cot square theta plus 1 plus tan square theta plus cot square theta. Equal to 3 plus 2 times tan square theta plus cot square theta. We have very nearly formed the expression for finding the minima. In the standard method of finding minima, the given quadratic expression, say ax square plus bx plus c, has to be converted to the form containing in part a square of a two-term expression absorbing all the terms in the variable x. Like x square plus bx plus c equal to p plus in the brackets qx minus r whole square. From this transformed expression, we can then mathematically conclude that for all real values of variable x, the square term will always be positive and hence will increase the value of the expression from the minimum value of p except when the square term is 0. With this knowledge, the target expression is finally transformed to the desired form as e equal to 3 plus 2 times tan square theta minus 2 plus cos square theta plus 4 equal to 7 plus 2 times tan theta minus cot theta whole square. The square term of this expression will always be positive except when tan theta equal to cot theta. So, the minimum value of the given expression is 7. Answer is option B, 7. To read the detailed solutions, refer to the article in suresolve.com. Link is in the description of this video. And please do subscribe to our channel for latest uploads. Thanks for watching.